Hi everyone, this is Miss Rapp and we are doing Algebra 2, Unit 6, Polynomials, and we are on Lesson 6, pages 72 to 76. Let's get started. Okay, so we are going to start by solving the polynomial equations by factoring. So let's take a quick look at this. I see that these are all even, so I can pull out a 2. And then we remember that we're going to be doing A times C that adds to B. And we learned about factoring patterns in the last lesson. So if what I'm about to do is confusing, please go back to the last lesson, check answer keys, ask questions in class, whatever you got to do. So I am trying to multiply to 18 and add to 11. And that's going to be 9 and 2. So I draw my, well, actually, guys, I don't even need to draw my area model because my A value is 1. So I know my factors are just going to look like this. So I'm going to set each piece equal to 0. I'll solve this one first. So I'll go like this. Everything with an x gets set equal to 0. So I'm going to minus 9 on both sides. I'm going to square root. Well, then I know x equals plus or minus. So that's going to be 3i because of that negative on the inside of the root makes that an I on the outside. And this is going to be x squared equals negative 2, square root, x equals plus or minus I root 2. Okay, we learned about I in Unit 5. Cool, let's try B. So I'm looking at all this and they all have an x, so I'm going to factor out an x. So now this matches the other factoring pattern. So guys, over here it was degree 4 and I have 4 answers. Remember, the degree tells you how many solutions you're going to have. And so this degree is degree 5. So one of my answers is going to come from this x. And now I'm trying to multiply to 8 and add to 6. So that's going to be 4 and 2. And because my A value is 1, I can just go right to this. That's a fun trick. So this is going to be x equals 0. There's one of my answers. And then the other two, so 2 live here, 2 live here. So x squared plus 4 equals 0, minus 4 on both sides, square root, square root. I get x equals plus or minus 2i, because the square root of 4 is 2, and the square root of that negative in there is I. Over here, well, we just solved that on the right. Oh, sorry, on the left. So that's going to be the same thing. Okay, that is your warm-up. Let's move on. Okay, guys, so let's write down these steps. So we're going to be graphing polynomials today in standard form. So we're going to be graphing, but instead of graphing from factored form, you're going to have to factor yourself. So let's get started. Find the degree and leading coefficient from standard form. Find the X-intercepts and multiplicity from factored form. Find the Y-intercept from standard form. And then it's really important that it's equal to 0. So you'll use your standard form and you'll plug in x equals 0, and then you graph. And then it says, please find the Y-intercept as well for all graphs. Okay, make sure you have this written down. Highlight anything if you have any questions. We are going to do 2 full examples on the video. Let's get started. Okay, I'm on page 73 now. I'm going to keep I'm going to keep my steps right next to me, and I'll reference them as I work through this. So it says step 1, find the degree and leading coefficient from standard form. So let's do step 1. So my degree is odd because it's degree 3, and my leading coefficient is positive. So odd positive, as we learned in the first lesson, is going to be down, up. Okay, that was step 1. Step 2 says, find the X-intercepts and multiplicity from factored form. So I'm going to have to factor this. And I'll just do this over here. So we learned from the last 2 lessons about factoring that I can use the area model here. So there's my setup. Take a moment, write that down. And let's just start taking out GCFs. -3, -4. So we get x squared minus 4 and x minus 3. And if we were trying to find the x-intercept, so I'm going to set that equal to 0. So now I'm going to set each of these pieces equal to 0. Well, this is just going to be x equals 3. And look, they both have multiplicity of this. So this out here is a power of 1. So the multiplicity of this is 1. The multiplicity comes from the outside. The multiplicity comes from the outside of the factor, not this. So like this is not multiplicity 2. If the 2 was on the outside, then I would say, oh, multiplicity 2 because it happens 2 times. All this 2 is going to do, all this squared is going to do for me is have me take the square root. So then I get x squared equals 4, square root, x equals plus or minus 2. And the multiplicity for each of those is 1. So my x-intercepts are, I'll go in order from least to greatest. So I'll go, it's -2, 1, and 2, and all of them are multiplicity 1. These are all multiplicity 1 because there's a 1 on the outside. Well, some of you can just say, well, Miss Rav, didn't you just put that 1 there? Yes, I did, but if it's not there, it's implied. Okay, so we did step 2. We just did this step. Step 3, find the y-intercept. So here's the trick, everyone. Your standard form, your y-intercept is always the constant, if you have it. So my y-intercept is at positive 12. So now we're ready to graph. So here's what I do. I'm going to mark my y-intercept, and I'm going to put a dot. And then I'm going to mark my x-intercepts. Okay, well, that's -2. That's 1. And that's 2. So I put my intercepts down. Then I draw my arrows. So I know it's going to be down, up, and I'm going to fill in the blanks. So remember, multiplicity, these are all pass through. This is a lot to think about, guys. So please make sure you're asking questions. So I'm just going to pass through everything. So I have to go up. And I'm not going to go down because I need to cross my y-intercept here. So your graph and a friend's graph might look different, but what I'm looking for are correct intercepts, correct behavior as you pass through, and then correct direction. So I'll write that down. Correct intercepts, correct end behavior, correct, what can I call that? Correct multiplicity behavior. And what I mean by multiplicity behavior is I mean, oh, because this was multiplicity 1, I'm going to pass through. So you only get multiplicity for x-intercepts, like the y-intercept you just pass through, like it doesn't bounce or anything on there. So we will see more intercept behavior when we get to number 2. Okay, let's get started. So these are what I'm looking for in your graph, because this graph can look different, but this is what I'm looking for. Okay, let's do our steps. So step 1, find degree and leading coefficient. So my degree is 4, which is even, and my leading coefficient is negative. So I'm even negative, which is down, down. So we already have our end behavior set up. Intercepts, so that was step 1. So step 2 says find x-intercepts and multiplicity from factored form. So I'm going to use all this space down here to factor. Unit 6 is intense because every lesson builds off the last lesson. My mom always used to say to me, well, did you understand the lesson before? Did you understand the lesson after? Math builds on itself. And I always used to get like frustrated when she would say that, but it's true. Like, especially in algebra 2, it really builds. So please make sure you guys are asking questions. because the more questions you ask, the better you'll do. So I'm going to factor out a negative 2x squared because that's the GCF. So then that becomes x squared plus 2x minus 3. So this is degree 4. So I'm going to have at most 4 intercepts and some multiplicity. So we'll look at that. So now I'm trying to multiply to negative 3 and add to positive 2. That's going to be 3 and 1. And the 1 is going to be negative. So I'm going to draw my area model. Okay. So here's what I have when I factor. I have negative 2x squared, x minus 1, x plus 3 equals 0. Okay, I'm going to set each piece equal to 0. Negative 2x squared equals 0. When I divide by negative 2, I get x squared equals 0, square root. I get x equals 0, but because of this squared, my multiplicity is 2, which is going to be a bounce. So I'll show you. Oh, sorry, you can't see that. So I'll show you guys what that looks like on the graph in a minute. And then I get x equals 1, multiplicity 1. I'll put a box around these, which is going to be a pass. And then I get x equals negative 3, multiplicity 1, which is a pass. We learned these all. We learned like the pass and the bounce in, I think, lesson 1 or 2. Once again, please talk to your teacher if you need extra help. So going back up here, I have x equals 0, multiplicity 2, x equals 1, multiplicity 1, x equals negative 3, multiplicity 1. So your multiplicity should add up to your degree. 2 plus 1 plus 1 is 4. Your multiplicity should add up to your degree. I'll even write that here. There are a few ways to know that you are right. Okay. So that was step 2. Step 3, find Y-intercept. So my Y-intercept, so I'll do this little section over here, Y-intercept, x equals 0. So I'm going to do y equals negative 2, 0 to the 4. I'm taking the original standard form. That's just going to be y equals 0. So my y-intercept is 0, 0. Okay, let's graph. So step 1, plot my intercepts. So let's do our intercepts first. So we have 0, 0, and that's our x-intercept and y-intercept. We have negative 3, and we have positive 1. And I know I'm going to be down, down. So correct intercepts, correct end behavior. Now let's move through this. So I'm approaching this negative 3. I need to figure out how to run through it. So it's multiplicity 1. So I know I'm just going to pass through it. Well, then I know I have to come down to cross through my y-intercept. And my y-intercept has multiplicity 2, so that's a bounce. So I'm going to approach it. I'm going to go down, and then I'm going to swing back up. That's my bounce. Bouncing, right, side to side. And then I have to peek up, and then I'm just going to pass through this and go down. And that is the graph. That's it. So I like to label these pass, bounce, pass. And that's just so your teacher really knows that you understand what's going on. Okay, a lot of information just happened. I would say that this lesson is where a lot of things come together. We will practice a lot in class. Have a good day, you guys. Please do your video check-in and good luck.